different angles and circles. There are two angles that we're going to look at, angles that are in the center. So this is an angle that's in the center. And we are going to look at angles that are inscribed. The first thing we're going to see is that the angles that are in the center this angle here is actually double the size of the angles that are inscribed. So that means that this angle here, if I double it, it'll fit, these two angles will fit perfectly inside this one here, if I line them up correctly. See? So those two angles together, so the angle in the center is exactly double the angles that I inscribed if they have the same starting point, the same ending point. The other thing you're going to see today is that angles that are inscribed, like this one here, if they have the same starting point as, so this angle here is the same as this one, and it's the same as this one. They all the same. They all have the same same measure because they have the same starting point, the same ending point, and they're all inscribed. So what you need to know is that angles that are inscribed are equal, and the angle that's in the center is always double. So let's do a couple of examples. So here the inscribed angle is 55. The angle in the center is going to be double. So that means that y will be 110 degrees. And here's the proof. So this angle here is going to be exactly double the one in the middle. So if I take this angle here and double it, it'll fit exactly in the middle. So as you can see, this is approximately half, and the other half here will complete the angle in the center. So this is 55, that's 55, both together are 110. And x here on top, they're both inscribed, they're equal. So x would be 55 degrees. And we can see that here, that this angle here is exactly the same as x. Let's do another example. So here we have a rectangle inside a circle, and we are looking to find the radius, so we need to find the length. The length. So we can do that by using Pythagorean's theorem, because if we complete here, this line here from here to here, we have 8.5 again. And the angle in the center here is 180. That means that this is a 90-degree angle. That means that this is the hypotenuse, that's the base. We can find the height of the right triangle here by using Pythagorean's theorem. So this is 18 plus 1, so 17 squared. That's the hypotenuse, minus 10 squared equals the length that I'm looking for of the rectangle, h squared. So that 17 squared is 289 minus 100 equals 8 squared. So you do 189, that's 8 squared. You do the square root of 189. You're going to use 169.
Mr. Reinders, please contact the office. Mr. Reinders.
And 196, that's your benchmark. So 13 and 14. You find the gap. Here there is a distance of 20, and here there's a distance of 7. So it's a lot closer to 14. So it'd be 13.8 would be the length of the rectangle. So the length of the rectangle would be approximately 13 and 8/10 centimeters. Let's do a final example here. So this one here, you're looking to find x, y, and z. So let's start off with y. So y, here I have a triangle that is isosceles because that's the radius, that's the radius, that's the radius. So this angle is equal to that angle. Now remember that all three angles always have to be in a triangle 180. So this and this and this is 180. So I have 100 plus the same thing twice, that gives me 180. So it has to be the same angle. So this is 40 and 40. So y has to be 40. All right, so let's take a look at x. Now here I have 100. Here I have 140. In a full circle, I have a total of 360 degrees. I already have 100 and 140. X is the remainder of the circle, and in a circle there's a total of 360 degrees. So what is x? X has to be 120 because it has to add up to 360. So this is 120. And here to find z, you apply the same logic that you did for y. So this is a radius, that's a radius. These two angles are the same. So you do 120 plus which angle? It has to be the same twice. That gives me 180. That angle has to be 30. So z has to be 30. Right, let's, here's your practice. Make sure you check your work behind the book.